continue with the second part of the packaging of DNA. Once again, look, listen, and learn. We just saw the nucleosomes in the previous module and how they are formed, okay? Now remember, the nucleosomes in a chromatin appears like beads on a string. Let us see what is beads on a string. Look carefully at the animation here. What you're seeing are the histone octamers. And now you're seeing the DNA wrapping itself around the histone octamer and then such joining the nucleosomes. Is that okay? So you're basically looking at this is how the DNA wraps around the histone octamers. Of course, there are several, and then now DNA starts condensing. Is that okay? And gives you an appearance like this, and this appearance is called as beads on a string. Is that okay? Right? We bring in the H ones. There you go. And that is how the DNA is packing itself around the histone octamers. Is that okay? Cool. Now look at this structure right here. What is this structure? You know that this structure is called as the nucleosome. Absolutely correct. Now look at the nucleosome. Now the DNA that has wrapped around the histone octamer in a nucleosome is called as core DNA. And the core DNA roughly has about 146 base pairs of double-stranded DNA. Now between the two nucleosomes you also have a small fragment of DNA. That DNA is called as linker DNA because it links the two nucleosomes. The linker DNA has roughly about 54 base pairs of double-stranded DNA. If you add the two, you can say that the nucleosome has roughly about 200 base pairs of double-stranded DNA. Recollect the diameter of DNA from the previous modules. It is roughly about 2 nanometers or 20 angstroms. Now when this DNA condenses while it is wrapping around the histone octamers, its diameter becomes roughly about 10 nanometers, okay? So the diameter of the nucleosome is 10 nanometers or 100 angstroms. The DNA has just condensed. In the next step, it is going to start coiling. And let us see how the DNA starts coiling. Is that okay? Look carefully. It is wrapping itself, correct? And then it is forming beads on a string. And then it is taking turns in a way that it looks like a coil structure. Observe very carefully how the DNA is wrapping itself around the histones, as well as now the DNA started to coil. Is that okay? Now what you see here basically is a structure that is made up of roughly about 1, 2, 3, 4, 5, 6 nucleosomes. Is that okay? Let's bring in the H1s. Now this structure, the coil DNA, is called as solenoid fiber. Okay, the diameter of the solenoid fiber is roughly about 30 nanometers or 300 angstroms. Is that okay? Look at the solenoid fiber. Don't you think it looks like the telephone wire? Yes, it does. That's how it has been wrapped, right? So you can say that the solenoid fiber actually looks like the telephone wire. Okay, that's it. Now moving on. Remember, the nucleosome and the solenoid fiber are characteristics of the nucleus at the interface. Okay? Now, let's move on with the packing further. What do you see here? You're seeing here is the solenoid fiber. You guessed it right. But remember, our DNA was very, very long, almost 2.2 meters long. So is this packing complete? Not yet. Let's pack it further. See what is going to happen. You're going to see solenoid fiber after solenoid fiber after solenoid fiber. The DNA starts to wrap coil, it tries to condense, and when it gets to the minimum side, it'll now start to supercoil. See how the DNA is supercoiling. Do you see that? It is coiling and coiling and supercoiling. It is twisting, it is turning, it is twisting, it is turning, coiling, supercoiling, and finally you end up with a structure that looks something like on my top. What is that structure called? You guessed it right. The DNA coils and supercoils and forms a structure which is called as the chromosome. Absolutely correct. Now this coil and supercoiled DNA is referred to as the chromatin fiber. This chromatin fiber have a diameter of 200 nanometers or 2000 angstroms. And look at the chromosomes. What does it have? It has two sister chromatids. And each chromatid has a diameter of roughly about 700 nanometers or 7,000 angstrom. Now look at that chromosome. This is how the chromosome appears in a compound microscope. And this chromosome is called as the metaphasic chromosome. So how does a metaphasic chromosome look like in a compound microscope? Just like this structure. What does it have? It has the two sister chromatids which are attached to that center green structure which is called as the centromere. Now you know that the chromatid was 700 nanometers in diameters. And when two chromatids come together, what do you think the diameter of this chromosome, entire chromosome? You guessed it right. It will be about 1400 nanometers or 14,000 angstroms. Is that okay? Here I finished the second part of the packaging of DNA. In the next module, I'll talk about the third part of the packaging of DNA. Thank you and take care.